1,000 years before GPS, a ship full of Norsemen could sail out of sight of land into open ocean under a sky thick with clouds and still find a speck of coastline thousands of miles away. No compass, no sextant, no maps as we know them. And yet, the Vikings crossed the North Atlantic, reached Iceland, Greenland, and eventually the shores of North America centuries before Columbus ever set sail. How did they do it? For a long time, historians assumed this had to be luck. Wild ocean, wooden ships, no instruments. Surely half of them just drifted into disaster. But the more we study Norse seafaring, the clearer it becomes that this wasn't luck at all. It was a system, a quiet, brutally effective science built from observation, memory, and an intimacy with the sea that modern sailors can barely imagine. Today, we're going to piece together exactly how they pulled it off, and along the way, we'll run into a mystery involving a strange crystal that scientists are still arguing about. To understand the achievement, you need to picture the world these sailors were working with. This is the Viking Age, roughly the late 8th century through the 11th century. Long ships were fast, shallow drafted, and flexible, built to handle open swells without breaking apart. But they had no below-deck cabins. No radio, no engine, just sail, oar, and a crew that had to read the ocean like a language. The North Atlantic isn't forgiving. Fog rolls in without warning, storms appear fast, and the distances involved are staggering. Iceland sits roughly 500 nautical miles from Norway. Greenland is another 500 or so beyond that. Vinland, the Norse name for the North American coast the Vikings reached around the year 1000, was even farther. That's not a coastal hop, that's open ocean navigation, out of sight of land for days at a stretch. So the real question isn't just, did they find these places? It's how did they find them again, on purpose, and bring people back? Think about what that actually requires. A modern sailor lost at sea today can glance at a screen and know their exact coordinates within a few feet. A Norse sailor had none of that. If he misjudged his direction by even a few degrees over a 500-mile crossing, he could miss an entire island. And missing an island in the North Atlantic didn't mean turning around and trying again next week. It could mean running out of food and fresh water in open ocean, with no way to call for help and no one coming to look for you. Every voyage was, in a very real sense, a bet on the accuracy of human observation. The first tool in their kit was the simplest one, the sky. Vikings were expert sun watchers. During long summer voyages, when the sun barely dips below the horizon at high latitudes, a sailor can track its position across the day and estimate direction with real precision. At night, they could use the North Star, along with other recognizable stars, to hold a steady bearing. This wasn't guesswork, it was a discipline, passed down and practiced constantly, because getting it wrong meant missing an island in an ocean with very few of them. But here's the twist. The sun and stars are only useful if you can actually see them, and the North Atlantic is famous for exactly the kind of weather that hides both. Thick fog, heavy overcast, storm-dark skies. So what did Norse sailors do when the sky simply refused to cooperate? This is where one of the most debated ideas in Viking archaeology comes in, the sunstone. Old Norse sagas mention a sunstone, a stone that could reveal the sun's position even through cloud cover. For centuries, this was treated as folklore, a bit of saga flavor with no real substance. Then in 2002, archaeologists diving on the wreck of a British warship that sank in 1592 recovered a chunk of calcite, a naturally occurring crystal known for its unusual optical properties. Calcite splits light in a way that can reveal the direction of the sun's polarization, even when the sun itself is hidden behind clouds or just below the horizon. Researchers have since run experiments suggesting that a calcite crystal, held up and rotated correctly, really can help a navigator locate the sun's position under overcast Nordic skies. Now, it's important to be honest about where the evidence actually stands. No confirmed Viking Age sunstone has ever been found on a longship. The calcite crystal was discovered on a much later shipwreck, and the experiments proving the technique works are modern reconstructions, not direct Viking records. So the sunstone remains a compelling, scientifically plausible hypothesis rather than a settled fact. What we do know for certain is that the sagas describe something behaving exactly like this, and that the physics genuinely checks out. Whether Norse sailors actually carried and used calcite crystals this way is still an open question historians and physicists continue to investigate. While the sky and possibly the sunstone handled direction, direction alone doesn't get you across an ocean. You also need to know how how far you've traveled and in which direction you're actually drifting, because currents and wind constantly push a ship off its intended line. This is where Norse navigation gets genuinely impressive. Sailors used a method called dead reckoning, tracking speed, time elapsed, and heading, then continuously updating their estimated position in their heads. There were no instruments for this in the way a modern navigator would use them. It relied on experience, an internalized sense of how fast the ship was moving through the water, and constant mental recalculation. And this is where the mini twist comes in. Vikings weren't primarily trying to sail toward a fixed point on a map, because they didn't really have maps in that sense. Instead, many historians believe Norse sailors used a strategy called latitude sailing. Rather than aiming directly at a destination, a ship would sail north or south along the coast of a known land, like Norway, until reaching the same latitude as their target, then turn and sail due west or east, holding that latitude as steadily as possible using the height of the sun or the pole star. Hold the latitude, hold the course, and eventually you run into land, because the position of the destination relative to the sun's arc was already known from experience. It's less like following a treasure map and more like tracing a line across a globe using the sky as a ruler. This latitude-holding strategy explains something that used to puzzle historians: how Norse sailors could reliably relocate places like Greenland after having already found them once. It wasn't about redrawing a chart, it was about repeating a known angle to the sun, day after day, voyage after voyage. Of course, the sky and the sun could only tell you so much. The final layer of Viking navigation came from something almost overlooked: nature itself, read like a live instrument panel. Sailors watched the behavior of birds, since many seabirds only travel a limited distance from shore, and a bird seen far out at sea could hint at the direction of the nearest coast. According to the Icelandic sagas, one Norse explorer, Floki Vilgerdarson, is even said to have released ravens at sea and followed the direction they flew to help locate land, a story that gave him the nickname Raven Floki. Sailors also studied the color and temperature of the water, the presence of certain marine life, cloud formations that can form above distant land masses, and the smell carried on the wind. Whales and seals tended to stay closer to coastlines, so spotting them could hint that land wasn't far off. Even the swell of the ocean carried information. Waves behave differently once they've bounced off a distant shore, creating subtle patterns a trained eye could sometimes notice. None of this was mystical. It was pattern recognition, refined over generations of families who lived and died by the accuracy of their reading of the sea, and passed down the way a trade secret gets passed from a father to a son who has no other way to make a living except by getting it right. Put all of this together, and you start to see the real answer to how the Vikings crossed an ocean without a compass. It wasn't one trick. It was a layered system. Sun and star positions for primary direction, a possible sunstone as a backup when the sky was hidden, dead reckoning to track distance and drift, latitude sailing as a strategic framework for actually finding specific destinations, and natural signs like birds and sea conditions as a final set of clues stitched into every decision. Strip away any single one of these methods, and the system still mostly works, because it was built with redundancy, the same principle modern engineers use when they design anything meant to survive failure. And this is the climax of the whole story. The Vikings didn't out-navigate the ocean with a single brilliant invention. They out-navigated it with attention, with generations of sailors who never stopped watching the sky, the water, and the birds, and who passed every observation down as hard-earned knowledge rather than superstition. Their achievement wasn't a gadget. It was a way of paying attention so consistently, so relentlessly, that the ocean itself became readable. That's how a wooden ship with a square sail managed to cross one of the most unpredictable stretches of water on Earth, find a landmass the size of a continent, and in some cases sail back home and do it again. What's left behind for us isn't a manual or a set of instruments in a museum case, though the Unatork disc, a fragmentary wooden object found in Greenland that some researchers believe may have functioned as a simple sun compass, gives us a tantalizing physical clue. Mostly what's left behind is the outcome: settlements in Iceland that still stand, evidence of Norse presence in Greenland, and the site at Lonso Meadows in Newfoundland, the only confirmed Norse settlement in North America, dated to around the year 1000, roughly 5 centuries before Columbus. It's worth pausing on how unusual that is. most of what we remember from history comes down to us as objects: a sword, a coin, a ruin we can walk through. The Vikings' navigational knowledge left almost nothing physical behind because it wasn't stored in tools. It was stored in people, in the muscle memory of holding a course, in the instinct to glance at a bird instead of a compass that didn't exist yet. That knowledge died with individual sailors unless it was actively taught to the next generation, which makes its survival across 3 centuries of ocean crossings even more remarkable. The Vikings never had a compass. They had something arguably harder to replicate: an entire culture trained to read the world closely enough that the ocean stopped being empty space and became a path.